Hello stormwater designers and welcome back to Clear Creek Solutions instructional videos. We're continuing to go over all the BMPs in the Western Washington Stormwater Manual construction pollution prevention portion of that manual. We'll have a link for the manual in the description down below so you can look at all this information yourself and get an idea of all the tables and aspects that go into BMP design. So now we're going to go into BMP C106, and that is wheel wash. The wheel washes reduce the amount of sediment transported onto paved roads by washing dirt from the wheels of motor vehicles prior to the motor vehicles leaving the construction site. You want to use a wheel wash when BMP C105, which we went over previously, stabilized construction access, is not preventing sediment from being tracked off the site. Wheel washing is generally an effective BMP when installed with careful attention to topography. For example, a wheel wash can be detrimental if installed at the top of a slope abutting a right-of-way where the water from the dripping truck can be unimpeded into the street. Pressure washing, combined with an adequately sized and surfaced pad with direct drainage to a large 10 foot by 10 foot sump, can be very effective. Wheel wash wastewater is not stormwater. It is commonly called process water. It must be discharged to a separate on-site treatment system that prevents discharge to waters of the state or to the sanitary sewer with local sewer district approval. Wheel washes may use closed loops, recirculation systems to conserve water use, and they shall include wastewater from concrete washout areas. When practical, the wheel wash should be placed in sequence with BMP C105, stabilized construction access. So suggested details are shown in Figure 2-32 wheel wash. The local permitting authority may allow other designs. A minimum of 6 inches of asphalt treated base over crushed base materials or 8 inches over a good subgrade is recommended to pave the wheel wash. Use a low clearance truck to test the wheel wash before paving. Either a belly dump or lowboy will work well to test clearance. Keep the water level from 12 to 14 inches deep to avoid damage to truck hubs and filling the truck tongues with water. Bid-point spray nozzles are only needed in extremely muddy conditions, and wheel wash systems should be designed with a small grade change, 6 to 12 inches for a 10-foot wide pond, to allow sediment to flow to the low side of the pond to help prevent resuspension of sediment. And then a drain pipe with a 2 to 3 foot riser should be installed on the low side of the pond to allow for easy cleaning and refilling. Polymers may be used to promote coagulation and flocculation in a closed loop system. PAM added to the wheel wash water at a rate of 0.25 to 0.5 pounds per 1,000 gallons of water increases effectiveness and reduces cleanup time. If PAM is already being used for dust or erosion control and is being applied by a water truck, the same truck can be used to change the wash water. Now we're going to get into maintenance standards. The wheel wash should start out each day with fresh water. The wheel wash water should be changed a minimum of once per day. On large earthwork jobs where more than 10 to 20 trucks per hour are expected, the wheel wash water will need to be changed even more often. Ecology has approved products as able to meet the requirements of this BMP. The products did not pass through the technological assessment protocol Ecology tape process. Local jurisdictions may choose not to accept these products or may require additional testing prior to consideration for local use. Products that Ecology has approved as functionally equivalent are available to review at the link below. You can see this on the slide. You can go to that link to view those products there. And then we get a diagram here of plan view, elevation view, and a section of the wheel wash. We can view the sewer pipes, the sump, and some of the other different aspects, and then a plan view showing the slopes and where the 6-inch sleeve and the curb would go in this situation. You can also find this diagram in the manual. Now BMP C107, construction road / parking area stabilization. So stabilizing roads, parking areas, and other on-site vehicle transportation routes immediately after grading reduces erosion caused by construction traffic or stormwater runoff. Roads and parking areas shall be stabilized wherever they are constructed, whether permanent or temporary, for use by construction traffic. High visibility fence shall be installed if necessary to limit the access of vehicles to only those roads and parking areas that are stabilized. On areas that will receive asphalt as part of the project, install the first lift as soon as possible. A 6-inch depth of 2 to 4 inch crushed rock, gravel base, or crushed surfacing base course shall be applied immediately after grading or utility installation. A 4-inch course of asphalt treated base may also be used on the road / parking area may be paved. It may also be possible to use cement or calcium chloride for soil stabilization. If cement or cement kiln dust is used for road-based stabilization, pH monitoring, and BMP C252, treating and disposing of high pH water, is necessary to evaluate and minimize the effects on stormwater. If the area will not be used for permanent roads, parking areas, or structures, A 6-inch depth of hog fuel may also be used, but this is likely to require more maintenance. Whenever possible, construction roads and parking areas shall be placed on a firm, compacted subgrade. Temporary road grading shall not exceed 15%, and roadways shall be carefully graded to drain. Drainage ditches shall be provided on each side of the roadway in case of a crown section, or on one side in case of a super elevated section. Drainage ditches shall be directed to a sediment control BMP. Rather than relying on ditches, it may also be possible to grade the road so that runoff sheet flows into a heavily vegetated area with a well-developed topsoil. Landscape areas are not adequate for this function. If this area has at least 50 feet of vegetation that water can flow through, then it's generally preferable to use the vegetation to treat runoff rather than a sediment pond or trap. Storm drain inlets shall be protected to prevent sediment-laden water entering the drainage system, see BMP C22, and then inspect stabilized areas regularly, especially after large storm events. Crushed rock, gravel base, etc. shall be added as required to maintain a stable driving surface. Following construction, these areas shall be restored to pre-construction condition or better to prevent future erosion, and then perform street cleaning at the end of each day or more when necessary. Now this is BMP C120, temporary and permanent seeding. Seeding reduces erosion by stabilizing exposed soils. A well-established vegetative cover is one of the most effective methods of reducing erosion. Using seeding throughout the project on disturbed areas that have reached final grade or that will remain unworked for more than 30 days. The optimum seeding windows for Western Washington are April 1st through June 30th, and then September 1st through October 1st. Between July and August, seeding requires irrigation until 75% grass cover is established, and between October and March 30th, seeding requires a cover of mulch or an erosion control blanket until 75% grass cover is established. Review all disturbed ends in late August to early September, and complete all seeding by the end of September. Otherwise, vegetation will not establish itself enough to provide more than average protection. Mulch is required at all times for seeding because it protects seeds from heat, moisture loss, and transport due to runoff, and mulch can be applied on top of the seed or simultaneously by hydro seeding. See BMP C121 coming up in the future here. Seed and mulch all disturbed areas not otherwise vegetated at final site stabilization. Final stabilization means the completion of all soil disturbing activities at the site and the establishment of a permanent vegetative cover or equivalent permanent stabilization measures. Now for design and installation, install channels intended for vegetation before starting major earthwork and hydroseed with a bonded fiber matrix. For vegetated channels that have high flows, install erosion control blankets over the top of hydroseed. Confirm the installation of all required surface water control measures to prevent seed from washing away. Hydroseed applications shall include a minimum of 1,500 pounds per acre of mulch with 3% tachyfer. Areas that will have seeding only and not landscaping may need compost or reel-based mulch included in the hydroseed in order to establish vegetation. Reinstall native topsoil on the disturbed soil surface before application. When installing seed via hydroseeding operations, only about a third of the seed actually ends up in contact with the soil surface. This reduces the ability to establish a good stand of grass quickly. To overcome this, consider increasing seed quantities by up to 50%. Enhance vegetation establishment by dividing the hydromulch operations into two phases. Phase 1, install all seed and fertilizer with 25 to 30% mulch and tachyfire onto soil in the first lift. And then Phase 2, install the rest of the mulch and the tachyfire over the first lift. Or you can enhance the vegetation by installing the mulch, seed, fertilizer, and tachyfire in one lift. Spread or blow straw over the top of the hydromulch. Hold straw in place, and both of these approaches will increase costs moderately but will greatly improve and enhance vegetative establishment. Irrigation, the increased cost may be offset by the reduced need for irrigation, reapplication of mulch, repair of failed slope surfaces, and this technique works with standard hydromulch. Seed may be installed by hand if temporary and covered by straw, mulch, or topsoil. Permanent in small areas, usually less than 1 acre, and covered with mulch, topsoil, or erosion blankets. The seed mixes listed in Table 2-34, temporary and permanent seed mixes, include recommended mixes for both temporary and permanent seeding. Apply these mixes, with the exception of the wet area seed mix, at a rate of 120 pounds per acre, and then consult the local suppliers or the local conservation district for their recommendations. The appropriate mix depends on a variety of factors, including location, exposure, soil type, slope, and expected foot traffic. So that is BMP C120. We're going to cover the rest of the BMPs here in this series, so you're going to want to subscribe to see more of our videos, and we'll see you guys next time.